An alkene is a molecule that has a carbon-carbon double bond. In this video, I'm going to teach you how to name alkenes. In general, we're going to follow the same rules that we use for naming alkanes. We'll begin by identifying the longest continuous chain of carbon atoms in the molecule, and then we'll number that carbon chain starting at the end of the molecule that is closest to the carbon-carbon double bond. From left to right, in this case, 1, 2, 3, 4, 5. This molecule doesn't have any branches on it, so we don't have to worry about that part of the name. The next thing that we need to do is locate the position of the carbon-carbon double bond along the carbon chain. Because the double bond doesn't have to be located here, it's also possible that the double bond could be located in a different position, like that. So we have to say exactly where the double bond is located. To locate the position of a double bond, since it does extend between two carbon atoms, we just use the number of the first carbon atom in the double bond. So again, even though the double bond extends across two carbon atoms, we only use the location of the first carbon atom or the number of the first carbon atom to give the location of the double bond. The first carbon atom of the double bond is a 1, and so that's the location of this particular double bond. And then what we're going to do is modify the name of the corresponding alkane. So for this molecule here, the corresponding alkane would just be a 5-carbon alkane. These are basically the same molecule, they're just only different in terms of a double bond. This molecule's name is pentane, so we're going to modify that name. Instead of saying pentane, we're going to say pentene. We're using pent because that is the indication or the notation for 5 carbon atoms, which is what we have. But we're going to change the ending to ene, which is our way of communicating that there's a double bond in the molecule. The ending ane is used when there are only single bonds, and the ending ene is used when we have a double bond. And again, the 1 in the front of the name tells us the location of that double bond. Let's try another example over here. So first we find the longest continuous chain of carbon atoms, and then we're going to number those carbon atoms. So starting at the end closest to the carbon-carbon double bond, which would be this right here. We just get to pick one of the carbons to be number 1. We could have picked this one, or we could have just as well picked this one here. Then we're going to number around the ring. And when we number around the ring, remember our goal is to give the smallest possible set of numbers to everything. So when we number around the ring, we want to number this way so that the numbering continues across the double bond, and the double bond gets the lowest pair of numbers in the ring. If we numbered the other way around, our double bond would be 1 and 6, and that wouldn't be the lowest possible set of numbers. So now we're going to name this alkene. First, we're going to say the location of the double bond. The double bond starts at carbon number 1, and that's what we use to indicate its location. And then we're going to modify the name of the parent chain. This is a 6-carbon cyclic molecule. If it was an alkane, we would call this cyclohexane, but because it's an alkene, we're going to change the ending to ene, 1-cyclohexene. Now, if you remember from one of the previous videos, when we have a cyclic molecule and there's only one feature to that molecule, like one branch or one double bond, we're actually not allowed to say 1 at the front of the name. So this molecule is just cyclohexene. The next 2 examples that we're going to look at have branches or halogens, so give us a chance to practice that as well. First thing we have to do is find the longest chain of carbon atoms, like this. And I could have also gone this way. It would have given me the same result. And now I need to start numbering this carbon chain. And this is where things get a little bit tricky. In the past, you've learned that you should start numbering at the end that is closest to the branch, which would be numbering from left to right. But since we are now working with alkenes, we have to add a new rule. And the new rule says that regardless of the position of the branches, you have to start numbering at the end that is closest to the alkene. We say that the alkene takes priority over the branches, meaning that when we're numbering this carbon chain, our job is to give the alkene the smallest possible number, and we don't care so much anymore about the numbering for the branches. So we're going to be numbering this from right to left so that our alkene can have the smallest possible number. This does have a branch on it or a substituent on it, so let's get that substituent named first. It's located on carbon number 3, and it's a 1-carbon substituent, so it is a methyl. When we name this molecule, we're going to begin like normal, so indicating the location and the name of our branch, 3-methyl, and then we're going to name the parent chain, or the longest continuous chain of carbons. This is a 4-carbon molecule with a double bond, so that means we have to start by saying where the double bond is located. The double bond starts at carbon number 1, so that's its location, and then we're going to say the name of the parent chain. A 4-carbon molecule would be butane, but this is an alkene, so we change it to butene. We have one more example to go. First, we're going to find our longest chain of carbon atoms. We have 5, 1, 2, 3, 4, 5. Now we're going to number that chain. And remember, our goal is to give the double bond the smallest possible set of numbers. So that means either this carbon would be number 1 or this carbon would be number 1. And we have to figure out which one of those 2 carbon atoms we should give position number 1. If we make this carbon atom number 1 right here, we are required to make this carbon atom number 2. So the double bond has to go continuously from carbon 1 to carbon 2, or from carbon 2 to carbon 3, or from 3 to 4, or so on like that. So if we call this guy number 1, then this guy right here is going to be number 2. This would be number 3, this would be number 4, and our bromine would be on number 5. If we number in the other direction, so if we call this guy number 1, our double bond has to go from 1 to 2. So this would be number 2, and the bromine would be on number 3. This would be 4, and this would be 5. So regardless of how we number this, the double bond carbons are going to be 1 and 2. They're either going to be 1, 2 like this, or they're going to be 1, 2 like this. And then in that situation, or in this situation, it doesn't matter which way we go with regards to the double bond. No matter how we do it, they're going to be 1 and 2. So that means we want to focus on giving the bromine the best possible number. When we numbered this way, the bromine got a 3. When we numbered the other way, the bromine had a 5. So we want to go the way that gives the bromine the smallest number, 1, 2, 3, 4, 5. Our bromine is on number 3, so we call that 3-bromo. And let's put this name together. Start by naming our halogen 3-bromo. Now we're ready to name the parent chain. We begin by locating the position of the double bond. It starts at carbon number 1. And then we say the name of the ring. Cyclopent, instead of pentane, it's cyclopentene. Because this molecule has more than one thing, it has a double bond as well as a halogen, we don't leave any of the numbers out. All of the numbers have to be included.